Okay, so hi everybody, I'm Lip. I do all sorts of stuff and I reverse engineer Mollies as well. I'm giving you an update now on what happened in the last year on the Molly side, or at least on the Lima driver side. Don't be too amazed, there was nothing showy like last year. There's no big demo, there's no big rabbit popping out of a hat. All I have is a hat at the moment, a bit of fur in there, a few bones. So yeah, a small bit of history for those who don't know it. I'm sure that many of you do know it because you're all FOSDEMers. You've been here before. So before, the 2010 and before, everybody noticed that ARM was becoming more than just Nokia, just the chip that drove the Nokia phones, or more than just pure deep embedded. Everybody was raving about Android. Organizations like Linaro were formed. And people started to notice that graphics drivers and other binary blobs were becoming a real problem. At the time I was at Nokia and we were dealing with imagination technologies. And we planned to work on, or we started working on making the power of VR more accessible and easier debuggable. And we wanted to go quite far with that, but sadly ELOP came in between and it never really happened. So during my time at Nokia still, we kind of formed this idea to reverse engineer something else, because obviously I'm burned on Power VR completely. Just like Rob Clark, that's why he ended up choosing Qualcomm in the end. So we basically formed a plan here at FOSDEM over a bit of coffee, like let's choose a chip that's probably going to be easy to open, a chip has a bit of a community. Let's choose a vendor which is most likely to become open, and we chose ARM. We were very wrong. So I got the only ARM-based, Mali-based hardware available. It was a Mali 200 on a very bad 7-inch Chinese tablet. And I spent the next year running around with that tablet in my laptop with a USB lead to in my backpack and a USB lead to my laptop. I could be seen at conferences with the USB lead always there and always tapping away at something. This is the nice thing about working on mobile devices. You don't have to drag a second laptop along. That's something new for driver developers, for graphics driver developers. Usually you have to have a second laptop or something, otherwise forget it. You're not doing any useful work. Or you're doing it on your own hardware, which is a pain. So yeah, I spent most of the year running around with that. First, it only had Android 2.1, no LD preload. So forget about interposing symbols as something you're not getting anywhere. I was poking with trying to hack the ELF binaries, which didn't get me anywhere fast. I was thinking about going to ptrace, but luckily somewhere around June, an image for the same device appeared with Android 2.3, and I got LD preload, so I got in business. So yeah, before nothing but talk, it just needed some stubborn bastard to go and do it. And I went and did it. And around FOSDEM2012, we presented it. There was just a few renders, a triangle, and what was it, a square, and a bit of a cube. And through a hack, I got the cube rotating. But it went off after 20 frames or so because I was just replacing the rotation, uniform the transformation there. And this is not good for the caching or so, and so the tiles were going off at some point. But that was FOSDEM 2012 and was a big breaking moment for free software graphics on ARM. Finally, people were thinking about it. Finally, it was possible. So over the next few months, people like Eric turned up and was watching this with interest. Eric used to work for ARM, and he was making a few hints, but he was very careful to not give us anything real, but staying like, oh, I wrote this nice shader. Please, Connor. When Connor turned up, go and take a look at it. That was what he was doing. Rob Clark was hanging around and thinking, yeah, Power VR can't do anything. I have nothing but Power VR hardware, can't do anything. Oh wait, I have this one device, it has a Snapdragon in it. So we started Freedreno. And then some 16-year-old, or 15-year-old kid showed up, which we learned afterwards. And he worked with Ben Brewer from Cothink, and the two of them started reverse engineering the shader side of Lima, which is a very important thing. I'll get to that later. At one point, we wanted to send him a tablet. And we asked him, where can we send this? give us your address. Where can we send this? I'll have to ask my parents. It was a bit of a surprise when we finally learned that he was 15. It was beautiful. But yeah, he's 17 and now in the meantime, and he'll be there for his next talk. So yeah, people were showing up, projects were being started. At Linux Talk, I spent another 2 weeks and I got a texture triangle, a texture cube, a companion cube. Spinning somewhat correctly was a very nasty mesh, but it worked. And after the summer, I think it was, yeah, it must have been September when Vladimir van der Laan turned up and first said, oh yeah, I poked at it a bit, and here's some of your state, like depth and this and that. He just bit down in a few hours and said, here it is. And is there anything else I can do? Maybe I can do Power VR. So I stopped, just like I stopped Eric at one point, stopped him from going Power VR, and he went with Vivante instead. So that's the 4 projects that are now running. So yeah, in the background I've always been working. I spent most of 2012 again with a USB lead to my backpack, to an Android device as well, poking at Quick3 Arena, trying to see what it needed. And this is what I showed you guys last year at FOSDEM, where we were actually proving that we can pretty much go anywhere. It wasn't just a few basic renders, it was we could go all the way, and we were faster, which is purely CPU based. I'll get more on that later. But it was a good proof of concept, and ever since then you guys didn't really hear from me anymore. So what have I done in the last year? Well, I was talking about not doing any memory management at all, and the first time I was here talking about Lima. There's no memory management, you just map it, you use it, and forget about it. The test program exits after a few seconds anyway, so forget about memory. So I added that on during the year because I needed that for VBOs and adding and removing textures. It's very, very necessary. I also started work just before the summer on actual initial Mesa driver, and that's about it. That's been the last year. So if you're expecting more, leave now, there is nothing more. But that's it really. But when I released the Quick3 Arena code last year, I needed a bit of a cleanup after FOSDEM because it's usually a mess, because the hacking that happens beforehand, it's just one big hack. Cleaned it up, threw it out, and the basic library, limare, was about 10 kLoC. In the meantime, the limare is 15 kLoC and the DRI driver is 5 kLoC. It's basically doubled. So nothing really spectacular happened, but there was a lot of churn in the meantime, and it's been tough going as well. So yeah, the hardware I'm working on, I should have actually included a picture, is an ARM board. This is what LibreOffice is running on, and this is why the reason why my laptop is there is because typing on that thing from here is not working out at all. So I have Serial connected, and that's how I'm now running LibreOffice, and I will start a few demos in a bit as well. This board is basically a dual-core A7 and A7. It's a bit badly numbered. It's well numbered and badly numbered. It's actually a cut down, really hard cut down A15. It has virtualization, and it's purely for power consumption. It's optimized for power consumption. So it's rather slowish, but it's a dual core. It works quite well. Compared to the tablet I had 2 years ago, it's a complete different world. It has 2 GB of RAM, which is why I trusted it with LibreOffice now. And it's running a halfway decent Mali at a not that decent frequency, but it's good enough. And it comes with, yeah, all the all-winner stuff comes with SATA. This even has IRDA and stuff like that, so it comes with everything you could possibly want from a board. The one issue is it's not completely open source hardware. The QB hardware is very open source friendly. It actually, the way this story started, probably Oliver in his talk this morning about Sangxi, explained how it started. Was a Chinese guy working for Allwinner, for the chip maker. Started shipping out TV boxes with VGA with a serial port you could access to Europe because you couldn't really get them before. And a kind of community formed, and they got talking, and that's how the original QB board ended up happening with the community of Sangxi involved. But no open source hardware. If you want open source hardware, that's available as well. You have to go and talk to a company called Olimex. They're also very, very open source friendly, and they're helping us a lot as well. And this board is, yeah, it's doing all I need for a good demo machine. You need VGA, which is what Eric forgot for his talk before. You need VGA to have universal access to a projector. You might remember the talk 2 years ago where I sat there with a 7-inch tablet in a dark room with 120 people in front of me, hoping that they would see the thing turn around. So luckily Will Stevenson from SUSE and KDE stepped in and handed me his laptop with a working camera. And I sat there showing off my belly, trying to keep the tablet, I was sitting at the other side, trying to keep the tablet in the image. It was not working well. I got better. I got an HDMI decoder the next time, which was a bigger issue because these things are 4x3 and these HDMI decoders are so stupid. They only do HD. So we had to go and hack the viewport directly in the driver so that it would look correct on the window and the colors were off. It was horrible. But ever since Sunxi hardware, it's become a lot better. Ever since this hardware came along, I can use an actual proper Linux. I have VGA. And it's running a standard U-boot. Well, not a standard U-boot, it's a Sunxi altered U-boot, but the plan is to get it all upstream. It is running a special Sunxi kernel. Sunxi is, the hardware is, the 820 is Sun 7i, for instance. The A10, one of the previous ones, that is actually quite similar apart from the dual core stuff. And the fact that it's an A8, Sun 4i and Sun 5i happen in between. That's why it's ended up being Sunxi. This is actually a forward-ported Android kernel with all the fixins as well. So it's a lot of ugly code, but it gets you full hardware support. And next to that, there is which I will be demoing, showing you later on as well, is an FBdev driver, which was, I think is here as well, Siamashka is his name, right? And this FBdev driver adds Neon, so for some of the copies. So it actually is a lot faster than most ARM hardware. It also adds, in our case for Sunxi, display support, and it adds the 2D engine as well. So it's actually a usable X driver, and that's quite fast. There's only one issue with it. At this point, it's optimized for the Mali binaries, which is using DRI to kind of liberally. And the CRA is having to do quite a bit of hacks to make this kind of visually pleasing, that it's not flickering. As a result, the proper driver is still flickering because we didn't have time the last 2 weeks to fix this. Anyway, Sunxi, one of the biggest issues that you have as an ARM GPU developer is that you're never doing just graphics. You have to do kernel, all other bits of kernel. I was hacking NAND stuff 3 weeks ago to get a device up, to get the flash access. You have to touch U-boot, you have to do everything. And if there's suddenly a community with actual tenure, a community with a future, some community that sticks with it, not just get an SoC, bring it up quickly, throw it away, move to the next one, and follow the mobile development cycle. That's not getting anywhere, that's just a rat race, you're just running around. Sunxi is a community that stays with it. We're still staying with it after 2 years. And it's becoming bigger and bigger still, even though the chips are a bit not as competitive as they could be anymore, but it's probably the freest device as well. So it is quite good for me as a Lima developer, as a graphics driver developer, to kind of focus just on the graphics driver side, which is why I spend most of my time rewriting the Sunxi wiki and not doing graphics driver stuff and kicking people to go and do things properly. One of the nice things about it is you can pretty much take any Android device and install proper Linux on it. If you're lucky, it takes an hour. Most of that is spent building a kernel. If you're unlucky, then you have to poke with NAND and this and that, but that's not that common. So I joined in 2012 when I was looking for a proper device to do demos with and to have talks with. And this one TV box came out, which Tom Cuby then started selling. And yeah, of course the vendor code is a mess. I will be talking about the display engine later on because I will need to talk to that. Actually, these are old slides. Oh well. And one issue is in the last 6 months or so, people have stopped just trying to get their hardware to work. They've moved on. They're now going for mainline. They want the SUNC kernel, all the bits ported to the mainline kernel so that it's always in the Linux tree. This happens, of course, in patch. This is a pretty patched job. They're bringing up interrupt controls, they're bringing up serial, and the next release, the next bits come along. It's usually completely written from scratch. We have a few data sheets as well, so that all helps. It's all possible. But if you look at, it also needs device tree these days. Everything is device tree, and this kind of the move to the device tree makes it very hard at this point to take any random Android device and turn it into a proper Linux device. And this is quite a dangerous thing, because if you look at the support there is now in the kernel, in the mainline kernel, it's just a few development boards. And that doesn't make the SUNC community any better than all the other ARM SoC development boards out there. So I had to become whiny again a few weeks ago and kick some people up the rear, and now they're working on a conversion from the SUNC way or the Allwinner way to device tree. So yeah, maybe next year I still have a device that I can demo it. Okay, so what have we been doing with Mesa? What is the Mesa driver looking like? Well, when I started looking into the Mali, the first thing I did was go look for the shader compiler. And we were lucky. ARM was exposing the symbol for the shader compiler. It was just there staring at you. After a few days, the format was kind of figured out, so we could just throw in the source, get back the Mali binary shader that comes out of it, which is a special format that ARM uses. And then I could focus just on one side of it. And this is why you also have two split talks today. Lima is actually two different projects. One of it is the bare driver, is the command stream, and that's what I'm doing. That's what I'm best at, just a black box that I'm poking at. I'm not a compiler guy or anything. I never will be. It doesn't really interest me either. The other side is what Connor and mostly Connor now, and Ben used to be doing, is looking at the shader. And this has been quite good because we've each been able to run as fast as we could. No synchronization was needed, and it's completely two different projects. At one point, we will have to join again and get them talking together, but it's just interface stuff. It's gonna be a pretty clean thing. The demos you'll be seeing is still using the binary compiler. This Mesa driver that's now running is still using the binary compiler, for instance. But as soon as Connor hooks into GLSL, and we'll get on that later, we'll be working with the Intel GLSL. As soon as that works, we can just swap them around as well. We can just swap one and the other. Swap the up layers of the driver, binary driver, or the Mesa driver. We can swap those, keep the compiler. Why not? We can see which one is slow, which one is buggy. We can swap everything back and forth, and that's quite a nice position to be in, because then you don't have to guess where the problems are. You know exactly where you need to be. And we have some hope that maybe we will actually be as fast or faster than ARM on many things. Now I'm using a standard old DRI Mesa driver for a very good reason. When I did the Mali thing, I'm going to have to speed up actually. When I did the Mali thing 2 years ago, I said, okay, we have the shader compiler. I can just throw this in Gallium, right? Some Mesa guys said, no, you can't do that. Why not? You just can't do that. It's not how Gallium works. You need to first start with the shader compiler and lay out your symbols before you can do all the other driver, the pipe driver beneath it or around it. And this wasn't working for us. We needed some way to get the source, the actual shader source, throw it in somewhere and get this binary shader back. And the only way that was offered me, that I was told at that time was, you can convert it to TGSI, some intermediate representation, and then you convert it back to source when you're down there, and then you can throw it in the binary compiler. Now, I think who was talking, was it that Ian yesterday? Ian Romanek was talking yesterday about how compiling shaders is taking so long, is most of the work on modern games. He has big stunking Intel hardware. We're on a Core i7. We don't want to make this extra conversion. It's just not working. So 2 weeks later, I posted about it on my blog and said, we're doing a standard DRI because that's apparently the only way. And then the same guy came back to me and said, don't you dare do an Intel to us. I'm not the sort of guy you should say that to, because then I will do it. That's that simple. Oh, well. Anyway, it's actually, that part of it is actually quite easy. I just need 2 more hooks that I can hook a bit higher into the old Mesa driver, so that I can just, it's called link shader and compile shader. The other driver hooks a tiny bit more low level, but very, very easy. And the other patch I needed is because it's C++ code, and there's bits of C++ code in this GLSL. And one of the types were not available. I couldn't access a sampler 2D. That's the other patch that I needed for one of the types. And this is even fixed in the latest Mesa. So this part of it was really, really easy. I'm also going for a standalone Mesa driver. This is very, very controversial in the XOR community. I still don't understand why, because I think people just see it as only more work and no gain. But I have no other option. I really have no other option. The Mali is pretty unique, just like Vivante and the one I don't like to talk about. We are a mix and match block. It's a sock with all the different blocks in between, and it's from different vendors, and they just buy a Mali, throw it in, and it should talk to everybody else. You don't get that anywhere else. You don't get that on Intel. You don't get it on PC hardware. You don't get that on a NVIDIA. You don't get that on a Snapdragon. So we are completely separate from everything else. Mali is a completely separate project from all the other graphics bits. You can't combine them at all. So it doesn't make sense to have it combined with everything as well. We also have very limited resources. This hardware is slow. You can't spend your days compiling Mesa. Limited free support. Well, my Lima driver supports, I think, 4 or 5 different kernel driver versions at runtime. Because I cannot count on the kernel being available. This is ARM hardware. We usually don't get the source. You don't get U-boot. You cannot exchange these bits. You have to work with this. And there is really a very limited audience, because when you bring this hardware up once, you don't want to change anything about it anymore. You usually spend, unless you're using Sunxi and the wikis I've been writing or the guides I've been writing, you don't want to do this again. You don't want to do this every week. You don't want to recompile, reinstall half your operating system just to test a new version of your driver. You will not get any driver uses because of that. And that's just why I think projects like Freedreno and perhaps Great and Vivante don't have that many users. I hope that as soon as this driver goes out, the users will be a lot happier. It's running autoconf, it's external. It only needs build system changes from Mesa, a bit of package config, and people can just pull in the new Limare, pull in the new Lima, make install it, done, they have the new driver. Doesn't work, try the old driver. Want to bisect? Try whatever you want. It will just work. If it doesn't work, then I did something wrong, and I have to go and find what broke between Mesa and the driver again, but that's a relatively stable interface, so it's not that bad. Yeah, and packages are, of course, available at sunxi.org, but for me, it's the most natural way to do things, and it will actually, I'm pretty sure it will help us get a lot of users out of this. But yeah, wait and see what the shitstorm will be on that one. Right, mix and match SLC again. We have a really, really big issue with synchronization. We are talking to 10 different display engines. We are talking to 10 different 2D engines. There are 5, 6 media engines out there. That doesn't happen on all the other hardware. Intel people are quite happy there. They only have this one piece of hardware. So that's pretty. That's a pretty big one for us. And we're pretty lucky that in the meantime, yeah, as Intel does, do everything over the 3D engine, and if you have to write something out to the display engine, if you have to flip something on the display engine, do it in the command processor, let it write out a register for you. You can hide it all in the commands processor and serialize it for you. We can't do that. We actually have to have buffers that can be synchronized. So the good thing about Linaro is that the DMA buff, and amazingly, they completely left out this sort of synchronization. DMA buff is multiple memories, it's memory from multiple devices that you can exchange with each other. There was no real standard before. Fantastic idea, we need it. But why didn't they think of synchronization? So luckily Martin Lankhorst, one of the Nouveau guys, has code for that. It's called DMA fence. And I've been begging him to do it. Finally get it upstream, help us. So this is what currently a frame looks like under Mesa. It's the last thing you want to see in a GPU. So Lima is just job-based. This GP job, a geometry processor, is a vertex shader and a tiler on one. This is a fragment shader, the pixel processor, and it just runs on each tile. This is all in asynchronous. I have 3 threads running in Limare just to do the job handling. One to listen to the kernel to say when the kernel says I'm done with this job, and the 2 others just trying to get this done, working through this whole thing. Lima has everything in memory, so you first map memory, do some GL, do some drawing, have a swap buffer, run the GP job and wait. And at one point it comes back and then run the PP job and wait again. And this comes all the way to Mesa, this comes all the way to user space. It doesn't even stay in the kernel. This is how the hardware is built. It's one way to do synchronization. And it's pretty painful. And once you've done waiting, you can finally go and tell X that it can flip or copy or whatever it is that it wants to do. And currently in Mesa, we have the issue that I can't optimize this further. I don't even know whether it will do a swap or whether it will do a flip or whether it will do a copy. I don't even know that when in my driver. I can't see that as the flush comes through to you. So this is really slow. You really want this happening here, and you want to do fire and forget and have the next block on the processor running, on the CPU running already, and you want to have these jobs running interleaved all the time. It needs to be handled automatically. And where do you need buffers? Where do you need memory here? You probably need some textures that some hardware generated for you, and you need to know that your buffer is available for rendering too. And then you just need to be able to fire that off to the display engine, nothing more. We don't have that now, and it will require quite a lot of work. First, display driver stuff, everything else, but maybe DMA fence will give us all that. And then we can have proper performance. But even though we use standard old Mesa, and we have the synchronization issue where we can't be any faster at this point, it is not too shabby. So let me first throw something out. Right. So I'm now running my standard Limare tests, the ones that I've created when I was starting to reverse engineer, or when I was reverse engineering the basics. These are very, very lightweight tests. And you see the flickering here. This is proper EGL. This is running over Mesa. This is the buffering issue. It probably will be something tiny, but it's still flickering. This is running about 500 frames per second at this point. This is the Limare version. This is just rendering to the frame buffer as fast as it can. And this is about 50% faster. And this is very low overhead. There's a bit of pixel shader stuff going on. It's very low overhead. And a bit texture involved. The pixel shader is a bit more active here, but still vertex shader is barely used. CPU usage is ignorable. So one of the, actually I could just kill it. It's not that important to watch this. Data is more important. So this is what we have here, 700 frames, 700 bit frames a second. And we're actually faster, than the binary here. Here we're actually slower for one reason, we're using textures. And Mali has a a special way of representing texture so that you can easily zoom or scale it. So you can very easily scale it. It's like a Hilbert curve, but then not continued, but just this expanded over the whole thing. And I can't properly implement it in Mesa right now, because as soon as you want to read from this thing, you get into trouble. You can do this on the CPU easily and get this swizzled over. But afterwards, you probably have to go and read from it, and that's not going to be nice. And it's probably going to be a lot of code and a lot of work. So Limaria does this. You never read from it in any way in Limaria, and you get full speed. And under Mesa, we lack this. That's why we're that slow there. It's the texture. And here, I think it's a synchronization issue. But for all these tests, we're pretty fast. We're better than the binary. And these are very basic tests. They don't exercise the CPU much. And what you're seeing, what I'm seeing, if I look at, for instance, time, I'm just looking at the basics. I'm just scratching the surface, not going anywhere deep with performance measurement. When I look at time, what the user overhead is and what the system overhead is. User overhead for the first two tests is 1/5 of what the binary does, because I'm using memory smarter. And the last one, it's 1/4. System overhead is 1/4 and 1/3. And this is where I got all the performance out of Quake 3 Arena last year. It's all CPU overhead. Everything else is just the same. Next one is ES2 gears, which, yeah, it just runs. Flickers a bit, but it runs. And you might have noticed that beforehand, these cubes that were rotating, they were rotating at different speeds. And this is very important for a driver developer when you're capturing command stream, is that when you're grabbing frame 5000 on the binary driver, it's the exact same render that you're looking at on the other thing that you're capturing. You need to have this not time-based, this is all time-based so that it looks nice. But for driver development or a benchmark, it's not very useful. Another thing that you notice here is that we're working on an ARM A7, Cortex A7, and everybody keeps on stating ES2 gears is not a good benchmark. It is, just not a good GPU benchmark. It's a really good CPU benchmark. It's a lot of tiny draws and then change the transformation, do a few tiny, just drawing a few teeth of all these cogs. It is a really good CPU benchmark. Compile it with O3, and you gain 50% of performance on this chip. It's purely CPU block there, which is very good because this 265 frames per second that I got, I fixed 2 hot pads in there already, and I was looking up symbols in the C++ code in GLSL. And I got, the same 50%. I was 81 frames per second beforehand. So it's really good for these tiny draws, for finding the hot pads there. I know that for normal frame drawing, I'm pretty good. CPU-wise, I'm very good for those very simple tests that don't exercise the CPU. These lots of tiny draws things, ES2 gears will show you that. It's a very good benchmark, just not for the GPU. It's for the driver and the CPU. And I'm still sure that I can find this extra 60 frames per second. They're there. There's still a few hot pads, and Perf will show that to me. That will be doable. Now, GL Mark II ES2. I have some of it running, not complete yet. So yeah, the standard horsey, this is used 5 different times in 5 different ways in this test, but this is just one. We're usually at this point about 10 to 20% slower. But yeah, the reason, I'm delaying putting out any code until this works. GL Mark II ES2 works at least. There's no point in doing anything else because it's just the basics. It works, it's just a bit slower. This is a nice one. It has 128 or 29,000. No, it has about 300,000 triangles. So that was a nice one to implement. And then the jellyfish, and then we're done. Yeah, textures, right. What is not working is desktop is not working yet because the old sound mesa guided me down the wrong path. There's a few hooks in there which probably should be removed, and I'll be looking into that in a bit. So the desktop test, it has multiple frame buffers and it's blending it, and it doesn't blend in the desktop case, which is not nice. And then there's one where I just return null for mapping a buffer, which then crashes, of course. And the Ideas in Motion is a more complex scene. I haven't even tried that yet, but that's all for the future. So performance-wise, it's actually not that bad a figure. If you look at what ES2 Gears was doing, if I can find a few hot pads still, then I'll get a bit ahead. Shading, Phong shading was actually a bit of a surprise. I need to go and look at that, but apart from that, it's looking quite good. Again, GL Mark II ES2 has the same issue as ES2 Gears. It's made for smooth rendering. It doesn't give you any sense about how many frames per second you have. You don't see it turning any faster, moving any faster if your hardware is faster. It's just time-based, and you cannot really you can't really measure it. You can't compare 2 frames of 2 different captures at any point except for the start, and that's not very useful for driver development. Another thing, when doing this sort of thing, you want to capture. It's a bit awkward code as well. It's C++ code that's not nice to read, and you cannot really cut it down easily. So if you want just render 1 frame of it, take the bits out, throw it in a bit of C code, and make it small and usable. It's very hard with GL Mark ES2. So you actually have to go and capture it with things like API trays. And the issue with API trays is it doesn't throw anything out to C code. It always stays in API trays format, and that doesn't really work for me either. But yeah, GL Mark II, despite a weird code and doing a lot of weird things, it catches your driver out a few times. So it is a nice test, at least. And yeah, I'm not too bad for a first approximation that isn't even complete. I'll find a hot pads at some point. So what will I do? Yeah, get full coverage, then clean up this mess that I made again, and throw it out. And Connor is also pretty far ahead with us. We'll talk about this now afterwards, and then we will try to incorporate both things. I need DMA buff, DMA fence to talk to all the various display media engines, whatever. And yeah, Sanxi display code, next talk. This needs to be done as well. Of all the targets, I should at least work on one. I can't go and do every new SoC that comes out every 6 months. I just can't. That's wasted time. And what really would be nice is to be able to rewrite some of the kernel stuff so that this job handling is at least handled in the kernel. It doesn't have to come back to user space. And I can do proper fire and forget. I hope that I get there, because that's where we will gain most over the binary driver. It's this integration with the display engine where we will be a lot faster than the binary driver. You don't get that right now. But the question is, should I really go that far as rewriting the whole kernel driver? Because we have a big issue there. The ARM Chromebook was released, what, a year and 3 months ago or something like that? And we're not really anywhere with that, because we've been too busy on this. But yeah, I spent 2 or 3 weeks in September on it, just to get a bit away from the slow work that it is to bring up a proper Mesa driver. And I decided to call it Tamil because it has a ring to it. And well, maybe it has a bit of a message for ARM as well. So yeah, it's a lot of core ideas of this chip are the same as in the old Mali, but a lot of it is just re-implemented by the same people. So a lot of things change, and there's not going to be that much code that we might share, at least not on the command side, on the command stream side. Wait and see. At this point, I only have a full capture and replay working, which is the start of everything. If you can't properly reproduce anything, don't bother reverse engineering. It's the first thing you should have is capture and replay. And I spent quite a while on that, and I had to go with ptrace in this case because I think it was some SMP issue or something. I couldn't get my LD preload work from the previous Mali working at all. So I had to take the scary option and use ptrace, which actually turned out to be very, very easy. I needed 2 kernel hacks, and then at some point I threw some stuff back into the hardware, and it didn't fail on me anymore. And I looked at the bitmap that I dumped, and it was empty. I spent another hour looking at all the code and trying different things, and just remained empty. And then I had supper, and then another half an hour looking at it, and then I tried looking at the actual bitmap, and then the alpha channel apparently was 0. So yeah, I turned off alpha in the BMP, and I had a nice triangle rendered. I've spent a few hours looking at this output and see if I could spot things, and left it at that. There's things that feel familiar at this point. I'm not deep enough. I didn't try anything apart from the smoothed triangle. So it will become better as soon as we go a bit deeper. And I expect to see more, but at this point it's not that good yet. And I also spent a few days on the shader compiler. We're going to play exactly the same game again as we did before. We have the experience. We're going to be really fast this time, because Connor now has all the experience with the compiler stuff and the shaders. I now have the experience of writing ESSL and OpenGL tests. I never did that before I did Lima. All the Mesa stuff will be a lot easier, will be a lot faster. But in this case, the symbols weren't available at all. That's just 2 days of work, and we have it available now. And we will have it available in future. It's just there. Even though our ARM tries to hide it, it can't run far. One big issue with the newer hardware, and with most of the chips, apart from Sunxi and maybe a few others, on the Chromebook especially, everybody, who here owns a Chromebook? Stick up your hands. Chromebook? Who owns a Chromebook? That's quite a lot of people, and few have it even along. It was the bestseller on Amazon for quite a while. But when in September I finally looked into it, I had the hardware lying around for 8 months already. Connor has had it since it came out, right? It was first in the US. When I looked at it and wanted to install a proper Linux on it, all the information on how to do that was from 2012. It was some people's blog posts, Olaf Johansson, he was the one who worked on it the most at the time, is the name that stuck to me at least. And he had moved on as well. There's no community there. There's nobody working Exynos 5 that I know of. Not at least in the Sunxi style, where you have a wiki, you have a mailing list, you have GitHub repositories, and this is what Sunxi is very unique in that sense, and where everything else is lacking. And this is holding us back a lot, because it makes the work of us graphics driver developers first and reverse engineering second, makes it a lot harder, because we're doing even more than just doing graphics. It's not just a bit of U-boot and a bit of Linux stuff. It's much worse, and it's surprising for the Chromebook because it's a very popular device.
Is that you have the you can run current U-boot. There is some work on mainline. The good thing is that there was some work on getting current mainline U-boot working, because Chromebook was one of the first target for virtualization work.
Yeah, that's the thing.
There is some work on getting a mainline kernel on it because of the same issue, virtualization. But yeah, community basically does not exist.
Somebody needs to go and do it. Somebody just needs to go and do it.
I tried when I got my Chromebook, and after something like
the way it worked at Sunxi, this guy Alejandro Meri just set up a website somewhere. We were talking in ISC channels. He ended up setting a website, creating a mailing list, and giving people access. It's just people joining together first on IRC and talking, and it grows from there. And I don't think it has grown for Chrome. And you mentioned why. Because people were focused on the virtualization of the A15 and then ran off to the next best thing.
Probably.
And that's the big issue for us. But yeah, thank you for your input. It's a big issue, and somebody please go and do this, so we don't have to do that as well. Now, before I finish, a few words from our sponsors. So what does ARM think of us? Well, let me get something that I can read out. We currently see very little advantage to ARM in the creation of such a driver and several disadvantages. I think the order is a bit wrong there, but in the meantime, they should see the advantage, but this was what I was told. And the fact that we are publishing documentation of their hardware that we reverse engineered. What are they afraid of, first off? They're ARM, they're sharing it with a lot of their customers anyway. They should have nothing to hide, and there is nothing to hide as far as I could tell so far. They have nothing to hide, and they're... What patents? Yeah, it's the ultimate stick. You can't prove it, and the last statement was a really funny one. If you wanted to open source it, we could just do it, perhaps. But if you're already scared of getting out a bit of documentation, imagine what the lawyers will think when you come, oh yeah, we have this big blob of code where so many people worked on. We need to get that out. That will never ever happen. The good thing is, apparently this is not popular opinion at ARM. It is the leading opinion of certain people. And the good thing about that is those certain people are not the youngest anymore, and I'm sure that he, as an ARM fellow, hey, as an ARM fellow, he will have a very cozy retirement when he finally goes, but it's not going to help us at all. So yeah, that was Lima driver. No rabbit, just a bit of bones and a bit of skin. Yeah, questions. Does somebody want to? Do I have to run around with my own mic? Questions? You're there.
Yeah. Questions? Turn it down. Microphone. You need to turn on.
Mute, yeah.
It's mute. Yes.
In the middle there.
Oh yeah.
I happen to own for, I don't know, 5 days already, 2 development boards made by the Korean manufacturer, which use an Exynos chipset, and they use Mali as a video driver, for video. How hard would it be to switch the images that exist now, use the binary blobs? I would be happy to help importing.
This is 2 different answers there.
Okay, let me rephrase. How can I
I'll give you
I
two.
help into porting the open source driver to the
It's not really a driver yet. It's just barely GL Mark II ES coverage, but we'll get there. 2 answers. I have Exynos hardware. It's a really nice one. It's a Exynos 4412 Prime. It runs the Mali at 800 megahertz. It is unbelievably fast. It's a quad pixel shader Mali. It's unbelievably fast. The actual quad-core A9 clocks to close to 2 gigahertz. So it's a real machine, a really nice machine that I used to build packages on for Sunxi. And it just works with Lima as well. I test a lot of Lima on it as well. Now I think for the next few weeks I'll be doing a bit more QB truck stuff because the Exynos one doesn't have VGA. Yeah. The thing is, the communities behind that are not existent. Sunxi has communities. It's easy to get your board up. No. QB is Allwinner. It's the freest. It's a dual core. It's not Broadcom. So it's dual core. Yes. And the issue that we have right now is that the higher end Allwinner devices are all using the manufacturer that I would like to talk about. And we're begging them all the time, please stop, please go back to Mali, even if it's an older one, please go back to Mali so that the community will support you. Because nobody really is working on the PowerVR based ones. Yeah, good choice. It's not as fast, yeah, sure, but it is miles ahead of what we had a few years ago. Two parts to my answer. No, that was it. It's a very fast device. I have it. Lima works on it. It just works on it. It uses it fully. It's nice to be able to work on a quad pixel shader at 800 megahertz. It's really nice. And I use it for bringing up Sunksy stuff, and you can install plain Sunksy stuff on that as well. You can use CRA as driver. You can use the binaries that we've halfway packaged, the binaries that we've gotten from the Qubitra guys all along the way. It's actually better to use the Sunksy stuff than to look at the manufacturer of the board, its website. It's easier. Oh, behind you. Can you? Oh. Who first? Anybody.
So then let me rephrase his question, please. What is actually needed to get whatever software you currently have into, a real driver form that can be packaged and included in distributions and actually used for desktops?
I left a really big pile of something. It's a big hack. There's code in there where 5 commits down the line I fixed the issues that happened before, and it's all thrown together. Just give me a few weeks to clean it up. First, give me the coverage. That's the first thing I need to do. Spend a few more weeks running with my head against the wall until GL Mark II ES2 works, and then I need a few weeks to clean it up, and then it goes out. Because if you're writing a project on your own, everybody's used to review. I want my code to be good, very good, but review if you're doing this on your own, you don't have it. And I kind of like to keep it that way as well, because that way I can just run and get somewhere. But that way you don't get good code. So it's not nice. It's nice to get somewhere. It's not nice community-wise, and you don't get good code unless you afterwards sit down and go clean up your own crap. But it will happen, and if that happens, the packages for the Mesa with the fixes that I need with a full build system, which is very easy. They're just Sunksy, install them, even on your old Droid. Install them on your Samsung device. Install them, it will work. Get the Lima tree, build the Limar library that even runs the direct tests. Get those, build that, make install. You don't need to do anything else. The other one, auto reconf. Make install, done. It's what it should be. Doesn't always work like that, of course, but.
Hi. So I was wondering, you said that the nice thing about Sunksy is that you have a community around it that takes away your work.
A bit, yeah. On the other hand, I'm doing a lot of work as well.
Yeah, no, sure, that's nice. I mean,
so yes, it should take my work away, but it doesn't in the end. Yeah.
So my question is, I have a Chromebook and I use it regularly as my main laptop now.
Mm-hmm.
I use the Chrome 3.8 kernel, but there's also work on mainlab, but I didn't get it to boot yet. So my question was, what exactly do you use or need from the community to get the driver working? What tools, like?
I think we're pretty much there. The next thing I need to do is go and clean up the display engine. And I think I'm very active there as well, and it's a very active community. The media guys, the guys that reverse engineered the media decoder do H.264 already. They were wondering, display engine, poking with the display engine. I'm working on that as well in display engine. That's the next talk after currents. I had to tell to them, just do DMA buff and DMA fence, and we'll work that out. What needs to happen there? Contribute. If you have hardware that, for instance, is not visible on our website, this is my pet peeve in the meantime. I slap everybody around the ears with that, because there's so many people who brought up their own tablet with the guides that were written with our software, and then they bugger off. And next that it comes around, it has to do everything from scratch again. There's no information about this tablet that this guy buggered off with. So nothing ever comes back. And the means to get Sunksy even bigger, because we have this ability to turn any Android device with this chip into proper Linux. The means to make that bigger is to get your device in our wiki and get it fully supported, get it in the repositories. So do that first of all things.
If I can interject you, sorry, but my question was about the Samsung Chromebook.
Samsung Chromebook.
Yes.
Okay.
There is no community. So what would you need to get?
Start by creating an IRC channel on Freenode. I don't think there is one yet.
No, there's just a Chromium dev thing.
create an IRC or Exynos 5 or something like that. Start with that and get people in. Anybody, make it a bit separate than just Chrome development. It's not Chrome development. It's not virtualization. It's this chip that we need to support, and the chip will last for a bit still. And it's quite popular. So start by the basics. Get some people together. Get some people together in an IRC channel. Get some server somewhere. Use GitHub. Use mailing list system, and just get people together, and it will happen.
So if I'm
Yeah, document the shit out of it.
Okay, that's a good point.
And clean up stuff. Start cleaning up. Make it easy for other people to install their stuff. Don't let us depend on a blog entry 2.5 years old or a year and a half old. Consta? And that's sadly going to be the last one.
I don't have a Samsung Chromebook, but I noticed that there's pretty recent instructions how to install hardware accelerated
Yeah, that's nice, isn't it?
yeah, so that's
half
that's
the
one
planet
thing.
is using Linux, is using the Sangsi Mali binaries that was packaged by a big asshole that ARM doesn't like. So it's nice to see that ARM is now throwing out binaries in a whole guide where you can install the binaries on the Chromebook. It's not that nice though, because for instance the patches on there are not really usable directly. So
Yeah. But so the most recent Chromebook Ubuntu installation is from end of October 2013. So it's not that old stuff. But
Yeah,
I haven't tried that, so
you will try that, okay?
I don't have a Chromebook.
They're cheap.
Yeah.
Drink less at FOSDEM.
No, I was gonna say I have GitHub. I don't know how many people know this, but I actually have a GitHub repo where I took those patches that weren't really patches, but just replaced this code here with that, and I actually have a GitHub repo with the actual patches.
Yeah, we have to go and do that. We run into this stuff and we have to go and document it. That's why I spend so much time on the wiki on Sangsi. Anyway, thanks a lot, guys.
I'll get you ready.
No, yeah.